when it comes to the Spark, definition itself, it's nothing but it's a general purpose cluster in memory computing system. Now, this is a bit kind of, it just needs a bit more explanation. When you talk about it's a cluster computing system, it's just like Hadoop. Hadoop is a cluster computing system, right? Distributed computing system wherein the computation is happening across multiple machines, right? Now, if you are running it in a pseudo cluster mode, your all daemons and everything would run, but again, the processing would happen only in one machine, right? So it's a distributed computing system. The thing is here, the processing, instead of happening it on the disk, it happens in the memory. Okay, so this is that's why it is cluster in memory computing system. Now, general purpose is another thing. General purpose means I can use it in the typical MapReduce fashion, or I could have used it in a typical functional programming fashion as well. Okay, so when it comes to Spark, it doesn't really restrict itself. Okay, it doesn't really restrict itself to the MapReduce programming style only. You can model your problems in the non-MapReduce way as well. But however, for all practical purposes, like it or not, I typically try to follow MapReduce process. Okay, so does it work parallel on different data nodes, different nodes in memory? Right, Vamsi. Okay, and that is supported by something called RDD. I'll come to that, resilient distributed data sets. I'll come to that part. Because I think the module number 7 is only about, so this is module 5, right? Module 6 is on Spark Shell, and module 7 is completely on RDDs, manipulating your RDDs and operations with RDDs. Okay, Vamsi, others, clear, right? Now, moving forward, so of course, since you are talking about the in-memory computing system, of course, your data analysis is going to be fast, right? There is no prizes to guess that. It abstracts the APIs in Java, Scala, Python. As of now, these are the 3 languages which are supported. And of course, basically you can express your programs into Java, Scala, or Python way. We are following Scala. If everything works out, probably that kind of small data visualization project or something, if I am able to demo it in the class, I would be doing it in Python because of the those statistical analysis capabilities side of it, right? Now, it provides you various high-level tools. The best thing is it provides, so it's not just the Spark core engine, which is, so it's just like MapReduce. MapReduce is a paradigm in which you can write your own jobs. But then when it comes to MapReduce, the beautiful thing about Hadoop is, or the thing which has made Hadoop more useful and kind of popular is, it has provided you various abstracts on the top of it, right? Pig, Hive, Scalding, Cascading, etc., right? It has provided you, or PyDoop. I mean, to name a few, there are a lot of things are coming up, right? So all of these are the high-level abstracts which have come on the top of it, wherein people from different kind of backgrounds can write their own specific programs, and then they can use the power, the computational power of the framework, right? So that's people who are from machine learning background and all, they typically use Mahout for Hadoop, right? So they can get the computational power of Hadoop. At the same time, they can perform the machine learning algorithms and all in a parallel fashion, right? When it comes to Spark, Spark has become so popular due to these reasons only. Continuing on the same discussion, you will see now. Okay, just a second. So in between there were some comments and all. So major difference between MapReduce and Spark is MapReduce doesn't run in memory, and this runs in memory. Okay, not really so. Probably, Vamsi, I would say, I would correct your question. Okay, your question is almost on the same line. I'm just correcting one part of it. I would correct your statement as, so the major difference between Hadoop and Spark is that Hadoop MapReduce processes don't run in memory, whereas Spark MapReduce or whatever process you are trying to run, it runs in memory. Got it? So I'm not comparing MapReduce with Spark. Got it right? Great. So as you can see that, just to tell, there is a Spark core engine, right? This is where you can write your own programs. On the top of it, there are various things which are either already built up or they are going to be built up, right? So Shark is one thing, and this Shark comes with a star. I will come to that. Spark streaming is another example, which makes basically Storm not really the subset of Spark, but yes, a very close competitor to Storm. MLlib for machine learning. Even though people say that, I mean, recently it has been announced that it is now not alpha or pre-alpha release, but still there are stability issues a lot. But let us see. Okay, remaining things: GraphX, SparkR, BlindDB, and other things also. Spark SQL, which is not even mentioned here, right? They are into alpha or pre-alpha releases. Basically, you know, you will see some of the things which will be coming very soon. Okay, they'll be coming very soon in future. In fact, some of the things which I am aware, okay, which is like, I know that people are working on it. So you know Pig, right? Pig is there in Hadoop ecosystem, and it is a very good data flow programming language. So not programming language, basically a data flow language altogether, right? So there are efforts which are right now going on. So just like you are integrating Hive with Spark, people are, and it used to be called as Shark, now it will be called as Spark SQL. But in future, you might see another thing called Spark, S-P-O-R-K. Okay, Spark plus Pig. You might see something. Now, coming quickly to a bit more, details about whatever I have talked here. So Spark core engine. Spark core engine is all about, it's a core engine for your entire framework itself. It provides the utilities and the architecture for the other components which are going to run on the top of it, or probably if you are going to write your own program, you can use Spark core engine, definitely sure. Next thing is Spark SQL or Shark, and then you can see that star with it. Typically, you will be using it for the structured data. You can expose many data sets as tables, and then, you can integrate it with Hive and then run your Hive queries unmodified. You can see those stars right now, right guys? This is where I was saying. So with Shark is something which, so entire this Spark thing was initiated by a company called Databricks. Okay, Databricks. Now, when they developed it, they named this project as Shark. Quite so, Hive plus Spark, right? Now, it is absorbed by Apache. And just for your own information, Spark is now a top level Apache project. This has achieved the top level status in the record time. Entire Hadoop framework could not achieve this that fast. So you can see that there is there is a lot of randomness. So, just in case if you are planning to use it in production, I would say just take a feel right now. Just create some POCs and all. Let it to settle for some more time. Because some of the features, there are some of the things which are not even mentioned here, guys. I have not even mentioned. There is something called Bagel. Okay. Then Bagel is like, it's like Pregel on Spark. And it is a competitor of GraphX. Now, right now there is no decision which has been taken. Okay. There is no decision which has been taken. There are talks that probably there would not be any Bagel. Its all capabilities would be transported to GraphX, and GraphX will be something which will be used in future, right? So those are some of the things which are happening very, very fast. That's why I'm saying it is good to know a lot of other things which are coming. And by the way, GraphX itself is not available as a beta release. It's just the alpha release which is available, right? So there is a lot of volatility right now, which is there in the Spark world, okay, as the name itself is, right? So just wait for some more time, and whatever is available, at least you can just start developing on the top of it. Things would stabilize very soon, kind of thing, right? Because it's a super fast kind of a development which is happening right now. Anyway, coming back to the Shark. So Shark was absorbed, and then there were other contributors and all. They somehow there are some changes where whatever they were required for Shark as well, and due to this, Databricks has now declared, it is like some 4 weeks or 5 weeks back announcement, probably more than that, but definitely not more than 2 months old thing. Okay, so they have announced that they have stopped the development for Shark. Shark development is stopped. They are going to support it. Okay, now Spark SQL is something which will replace. Okay, that's why you are seeing Spark SQL / Shark. Okay, Spark SQL is something which will replace Shark going forward. Now the point here is Shark could be used with Hive easily, but right now Spark SQL, it is, you can expose your text files, you can expose your Parquet files and other files as tables, perform your queries. But right now there is a Jira which is open, wherein the Hive team and the Spark team as well are working for the integration. That release has not yet happened. Okay, I think I have that Jira number as well. Okay, so here, once that will be done, I think that would be the time when Shark will be closed. Okay, right now Shark is just supported. It is no further release will come. It is just supported. Okay, once the Hive integration is over with Spark, then I think probably that GitHub repository for Shark will be closed as well. Is this clear to everybody? Why I am writing Spark SQL / Shark? And just in case somebody asks you, I hope it is like, it should be crystal clear to you. Now, point is, Vamsi says, just to get clarity, Spark doesn't generate any MapReduce. Am I right? You are right. You can write, I mean, it can generate MapReduce for sure, but not Hadoop MapReduce. You can program, or you can write your programs in MapReduce way. So MapReduce is a paradigm, right? You will see that. I'll show you word count. It has got map, it has got reduce, but they will not run as a Hadoop MapReduce. So Spark SQL uses Hive. Is it correct statement? No, it will use. As of now, so point is, when you talk about integration, what do we mean by this? We mean Shark is using Hive Metastore and then immediately accessing the data and then running it. With this, your processes become fast. But when you talk about using Hive, it will not use Hive to run, spawn the MapReduce jobs. Is this clear? Niranjan, that was the answer of a question. Okay. Vamsi says, yeah, so I can write MapReduce, but run them on Spark in memory in parallel. Hope I am correct. You are 100% correct, Vamsi. Okay. But again, those MapReduce would be written in Scala. So when to use Spark SQL Shark compared to Apache Hive from data perspective and speed? Completely from the speed perspective. Balaji, completely from the speed perspective. Great. Now I'm expert on Spark. It is just the first step, Vamsi. Anyway, many new things would come. Okay. Now, so this was about Spark, SQL and Shark, the clarity on this part. Okay. Spark streaming. Now, Spark streaming is something which is interesting. Okay. Spark streaming has got a bug. Sorry. Okay. Spark streaming has got a bug. right now, all those examples, there is, I think, some Jira which is open here. They say that, in fact, I also tried doing it. You try to open two different, so Spark streaming works, okay? As far as you are watching some directory, it works. But if you are trying to watch, let's say, on the terminal from which the direct data is coming directly in the form of a stream, right? One terminal to the other one, this has got some bug. I don't know when it would be resolved, but for all the practical purposes, if you want to integrate, let's say you really want to integrate, Spark to one of the distributed messaging queues and all, it is possible. You want to watch some directories and all, it is possible. Though I have not integrated it with any of the queues. This is never my use case. Neither I have prepared any kind of examples for it. But I do have some sort of links, or I do have some sort of example codes also which are there. But again, for that I have to set up Kafka, or I have to set up some other things which I have not tested as of now. Okay, but what I have done for Spark streaming, which I will be showing in, I think, module 7, right, module 7, RDD and Spark streaming is something which I'm showing. So that I would be watching a specific directory. Okay, that directory can be anything. It can be your Linux directory, or it can be your HDFS directory. Okay, and then that time I was talking about this, right? Sliding window word count and all. Actually, I'll be running only that sliding window word count example for you. You can try anything, whatever, whatever comes in your mind. So the word count is for a very good reason, right? It covers mappers, reducers, everything. So whenever you have another use case, you can modify it and run. Okay, so that would be about Spark streaming. BlinkDB. BlinkDB is something which is interesting. I'm coming to those questions which are being put. Now, BlinkDB is something which is an approximate query engine. Okay, it's like I think I had talked about it, that there is an event which is going on, and let's say there are 500,000 some XYZ number of tweets, right? 50897 something, right? So this many number of tweets are there. You are not really interested on the exact number. When you just want to run it, you just want to know, okay, there are 500,000 plus tweets which are there, right? So this is something which will be done by BlinkDB, which is an approximate query engine. It typically works on sampling of the data, and then gives you the approximate results, not the exact results. Right? Guys, clear, right? That's why it is called BlinkDB. Response times is going to be very fast. It's going to scan everything, but by sampling. So it is approximate results. Okay, as of now, I have not heard any word on it, but it is just mentioned. Okay, now Shekhar says tried Kafka, publish, subscribe, and it worked like charm. Great. Shekhar, please do share it with me as well, because typically I work on these things and I share it with people when I have to I have to work on them. So probably it might help in improving the contents also, right? Sure. So Balaji and others, as soon as Shekhar sends it to me, I will be sharing with everybody. Okay. Thanks a lot, Shekhar, for helping. I'll appreciate it. Harsh, we have a person here in the class. Shekhar. Okay. Now coming to MLlib. MLlib is the machine learning library, which is built on the top of Spark. Again, you know about it. And right now it's all about your algorithms, which are like Mahout and all. So the other thing is the next version of Mahout is also going to be migrated to MLlib. Okay, that is something which is going to happen in near future. I don't know which is that near future thing, but yes. So right now itself MLlib has got some algorithms. They are not yet fully operational, but they are planning to come up with the next release, which will be getting more algorithms built within it, and you can hopefully use it. Graphics is the other one, right? So it's basically similar to Giraffe for the distributed graph processing and all. Again, it would come up. Right now, all those star things are like WIPs, right? Work in progress thing. Spark R, just like you have R Hadoop, of course, everybody wants to leverage the best thing, right? So for near real-time kind of processing in a distributed fashion, people would go for Spark R. Okay, so these are some of the things which are quite popular, right? Now this was about the ecosystem. Now let's talk about why part of it, right? By the way, so Shekhar, with this I assume that you are you using Spark in production, just in case, as a mutual interest I am asking. Oh, okay. So just as a kind of a POC or something, right? Okay. That is great. Can Spark R read the data from Shark? Vamsi, no idea. There is no release as of now. So there is nothing. Okay. So there is no release. There is no API available. But when would I use Storm compared to Spark? Simple. You want your data or okay. Satya, can I keep this question for last? There is just remind me about this question. I'll answer it. Okay, for a reason I'll answer it a bit later. Now, why Spark? So Spark exposes, you know, that it's a simple computational model and all. That's not the big thing which I want to focus. The good point is about the second thing. The Spark framework, which is something which can be developed, you know, deployed through multiple is a marketing term, through 3 different cluster managers. It has got its own cluster manager. It's called Spark Cluster Manager. By the way, you will be hearing one term very, very often: Spark standalone mode. Spark standalone mode. Okay, standalone mode does not mean that a single machine. By the way, right? Spark, just to tell. Okay, Shekhar, you must be aware, right? That Spark standalone does not mean the single machine. Standalone means you are using the Spark its own cluster manager itself. This is a kind of a misnomer which I found. Okay, so if there is a Spark own cluster manager, if it works in that way, then you are calling it a Spark in a standalone mode. Or you can Spark is something which is you can just use with the other cluster managers as well. You can use Yarn, you can use Mesos. Mesos is something which we do not cover, which I have not at least covered in this. But yes, you can integrate this Spark thing with any of these 3. Okay. However, there are some links wherein people can use it, but I have not, at least in the practical, some 2-3 domains wherein people are using Spark or trying to use Spark. I have not seen anybody using Apache Mesos as of now. Okay, if somebody of you is using it, you can let me know about it. Okay, Spark framework is polyglot, nothing new. Scala, Java, and Python. These are the 3 things which are supported. It has got super active community. Again, not a new thing which is there. It fits well with the existing Hadoop ecosystem. That is the best thing, right? Which we have already talked. It can be launched in the existing Yarn cluster. It can fetch the data from Hadoop 1.0. This is important. Guys, see this second point. If you just want to use, Yarn or Spark with Hadoop just for the storage purpose, you don't really care about the processing. You can still use it with Hadoop 1.0. Guys, important thing. You can note it down. Okay. It can be integrated with Hive. Right now using Shark. In future using Spark SQL. Okay. I've used it with Hadoop 1.0. Okay. So the point is, depends. What is your use case? If your use case is only for the integration with Hadoop, only for the storage perspective, go ahead. Use 1.0. You don't really need to use 2.0. Okay. Now it is a brief about history. Okay. A brief history. Again, not a big deal about it. 2002 MapReduce paper got published. and all that stuff. You know about all that Hadoop thing, right? I'll come to the Spark part. 2010 was the time when Spark paper got published. It was hardly 4 years back, right? Now, it is only in 2014. You can see this. 2002, right? 2002, this got published, and around 2006 or probably 2008 or something, it became a top level project. 2010 is something wherein, you know, the Spark paper got published, and then the open source implementation and then kind of, you know, becoming top level journey is only in 4 years. This is the fastest one, okay, which has happened. Animesh says, what does it mean by a top level project? So Animesh, you know, Apache has a process. They typically take a project for the incubation first. They incubate it, and then in that they assign some of the resources. They create some sort of, you know, open those repositories, and then they see how is the response from programmer community. Is there are some good contributions which are coming. There are some sort of, you know, good additions which are happening, and if it excites well, then it goes to the next level. From the incubation stage, then they own it, okay, and then, you know, if it gains more traction, then it becomes a top level project. So all of your projects, right, Hive, Pig, all of them were initially the incubated projects, then they become the sub projects, and then they became the top level projects. Okay, Animesh. Niranjan says, Storm cluster versus Spark own cluster, please elaborate. Storm cluster? Where did you see Storm cluster in this website? Sorry, in this particular Nimbus. Okay. So that's a different thing. I think Partha or somebody has asked this question. I think that discussion will be useful for you. Okay, Niranjan. Now, so coming to the point of, you know, so if MapReduce and other things were really so good, why actually have we moved towards, you know, this? You know already a lot of these details from the, you know, that example discussion which I had with Vamsi. But again, MapReduce is very powerful programming paradigm, but there are some limitations. The first limitation is, you know, you want to implement a particular problem in MapReduce, you have to start thinking in the terms of key values and nothing else, right? It is a basic basic assumption. If you cannot explain your problem in the terms of MapReduce key value pairs, you cannot solve it via MapReduce. As simple as that, right? So it's a bit difficult thinking, right? I mean, it's a change of paradigm altogether. There are some performance bottlenecks, right? So exactly as I think probably Vamsi has also mentioned, and others must be knowing from their experience, that if you have the small batches, right, they typically do not fit for the use cases altogether. So I mean, from my personal experience also, I can tell you, not all of the programs are actually made for, you know, MapReduce itself. If Hadoop is typically said very good for small number of large files versus large number of small files, okay? So until unless you bring one extra layer, you cannot really straightforward go ahead and implement, you know, your jobs in kind of, you know, MapReduce paradigm altogether. There are several types of algorithms which are not supported. Iterative, all about iterative algorithms, iterative or recursive or asynchronous algorithms themselves, right? They are typically, those are the different kinds of categories of algorithms which do not find any support in MapReduce. So these are the limitations of MapReduce. I'm not saying all of them are overcome in Spark. Okay, so please note it, not all of them. Asynchronous, for example, it is not yet supported. Okay, they are not yet supported in Spark as well. But yes, these are the limitations of MapReduce. So in short, if we have to say, you actually, you know, so MapReduce doesn't really fit well for all the kind of you know, problems. Then people typically go for kind of hybrid approaches, right? Use Hadoop streaming, use some sort of, you know, your own scripting language, and then create some kind of, you know, shell scripting on the top of it, a lot of other things, right? And then typically, if you have not used it well, you know, there's a basic law, right? More the number of variables, more is the instability thing, right? So this is how it goes. So again, these were some of the limitations which people realized also. Then over a period of time, right, people saw that, and then depending upon whatever was their area of interest, whatever was the area in which people were working, a lot of specialized systems have evolved. So the next slide. So brief history about the evolution of the specialized systems. So MapReduce provide a base. Okay, MapReduce, you know, provide a base for it. Now with this, there were a lot of, you know, these Talkout, Pregel, Dremel, Drill, Taze, Giraffe, GraphLab, Storm, S4, Impala, all of them, right, are nothing but the specialized systems altogether. So they are based on MapReduce. Talk about Impala, it claims that your Hive queries are going to be, you know, almost 100 times faster or 1000 times faster. There is something called Stinger, which I have not even mentioned. Okay, Stinger also says nearly the same thing. Talk about Taze. Taze is another way which just says that, you know, through which you can write or MapReduce in a much easier way. Okay, PyDoop, another example. Giraffe for the distributed graph processing. Actually, GraphLab, Giraffe, Dremel, all of them are nothing but the, you know, different ways of MapReduce implementations. Okay, so they are nothing but different, you know, as you can see, specialized systems, iterative, interactive, streaming, graph, etc. Depending upon which way, which kind of problem you are trying to solve, these were the different specialized systems which evolved over the period of time. Guys, are you there with me? Is it heavy? Is it slow? Or is it too obvious kind of thing? Right? Right. Can we say that these are MapReduce frameworks? No. These are the different ways of MapReduce implementation. So, for example, Giraffe and all, they are the implementation, or they are the, essentially, if you look at them, these APIs do not do anything other than the iterative MapReduce. Okay? Right? So, these are some of the things. What are the issues if she runs Spark on Hadoop without yarn at a high level? So, Vamsi, I have to cover all these things. Yes. I will naturally come to these. Right? Now, so it's about, so you must have seen all of these were the specialized systems which were dealt for a specific kind of problem statement. But when it comes to Spark, it is not a specialized system. Its design goal is to generalize your MapReduce concept to support new apps with the same engine kind of a thing. The two differentiations, okay, so you must have seen it, right? Spark core engine. You want to do machine learning, MLlib is there. It will be enriched. You want to do some sort of structured data processing? You have the answer, Shark or Spark SQL. You want to do some sort of graph processing? Very soon, I think alpha is released, but not the beta one. But yes, GraphX is something which is there, right? So or probably BlinkDB or Spark are not yet released, but they are on anvil. Very soon you can expect, you know, these things to be coming. So it is not a specialized system. It is the collection of multiple utilities. So it is no more a specialized system altogether. It is actually a framework which, just like Hadoop, right, provides you various utilities to do whatever you want to achieve. Right, guys? Is it making sense to all of you? Guys? Right? Kind of, right? So I'm just in the last part kind of thing of today's presentation. Now, so there are two specific things which are common across different implementations of Spark. One is you have fast data sharing. Fast data sharing, typically you are loading the data into the memory. Second, general DAGs or directed acyclic graphs for the lazy processing. Okay, I'll talk about it. there is something called transformation, and then there are something called action. Okay, so till the time you do not take any action, your transformations are just calculated. Nothing, no actual processing happens. So these are typically called lazy processing. If you are aware of something called lazy vals, if you remember, Vishal talked about it sometime later, right? You would remember these things, right? They would be useful. Okay, so this allows basically an approach which is more efficient for engine and much simpler for the end users. Come on, this is the line which I myself have written, but it's like it's too obvious by now, right? Now, some of the basic things, right? It is from the code perspective. For the, assuming that you have a same kind of whatever code requirement, this is the approximate, code lines. This thing: Storm, Streaming, Impala, Giraffe, Spark. And by the way, this is not from me. This is the state of Spark and where we are going next. This is one of the nice use cases or nice, URLs, videos. You can actually refer that anyway. Okay. Next. So this is about the brief history of Spark and Spark key points and all. So guys, it's about, there is RDDs are the base here. Resilient distributed data sets all together. Okay, so what happens is all of those transformations, can you see this dot filter, dot map, dot something, right? Whatever we talked about, that you will see that in practice. Okay, you will see that in practice in the coming examples and all that stuff also. Now, what would happen in these cases is all of these things are the different transformations which happen, and RDDs are something which are very, very which are designed for the fault tolerance purpose. So for example, you had a base data which was quite huge, right? And then you calculated it, you saved it in the memory somewhere, and then you did another transformation. Probably you again saved it in the memory, or I don't know whether you have not saved or something, right? Now, what happens is, what would happen, let's say you calculated it, your base data set is intact, but the place where you had kept it in memory, let's say through 2-3 machines, right? One of the machine goes down, right? What would happen, right? And probably the result which went down was, let's say, the result of dot map, not the, or rather than dot map, it was the result of dot filter or something, right? So these might be some of the things, right? How does it happen? So RDD actually, takes care of the lineage itself. It basically takes care of the sequence in which those transformations were done, and it automatically recalculates them. So that kind of, fault tolerance and other stuff are built directly into the RDD stuff. You don't really need to worry about it, right? This was one. Other thing, this is something which is interesting. This is about RAM. Now RAM becomes a very important part. I think Vamsi, if you are hearing me, probably this is just the starting point. There are much more elaborated discussions which will follow, right? So you have RAMs and all, right? You are now memory hungry kind of a system, right? Which typically you would like to have more RAM than a traditional Hadoop data node, right? So it will spark, or I would say it will initiate under discussions when to go for, or how do you convert your cluster to Spark cluster and all. But anyway, coming back to this point, you can actually see that if you have completely cache which is disabled and you have a collection which you are trying to iterate, this is the actual time. So if you have fully cached, probably around 12 seconds or 12 milliseconds or whatever, right? If you have cache disabled, it is up to 70. And then depending upon how much you are putting in memory, you put 25% this much time, 50% this much time, 75% this much time, and fully cached is 12, right? So you can see that there is a graceful degradation of the performance. It is not like, complete disgraceful degradation which happens here, right? So depending upon what exactly is the capacity, how exactly you are going for the, memory to disk partition of your memory, right, of your data, you will get different kinds of responses. this is where we'll just start getting into the bit more details of what exactly is Spark architecture as such. This, I'm sure those people who are following Spark on internet, they must have seen some part of it, but now we'll just talk, a bit more detailed discussion about it, right? So guys, always, whenever, you would interact with Spark in any mode other than Spark Shell, right? Even though Spark Shell also does nearly the same thing, but let's say that you are interacting with Spark in the form of a simple Scala application. I will come to Scala application today, wherein I will have to show how to create your simple Scala app and then submit it. Now, in that case, what happens is you would be having multiple classes altogether, and then definitely there would be a single class which will be having your main method, right? Just like you have public static void main kind of thing. So similarly, you will be having your under the same main method altogether, which is typically called the driver program. And SparkContext is the object which gets created then and there. Okay, SparkContext is something which is kind of how would I give the parallels? Okay, so it's just like your job conf in Hadoop. Though it is not exactly job conf, you have something called Spark conf, but it's like your context object altogether, right? So it is just like your context object in Hadoop jobs and all. Those people who are not aware of Hadoop, you can just think that this is your wrapper. SparkContext is actually a Scala class altogether, okay, which basically you will be setting multiple parameters to it, and then this is something, SparkContext object is something which is responsible for entire execution of your job altogether. So what happens from SparkContext to the cluster manager and then to the worker nodes and all? In order to explain it, I'm skipping it. I will come back to this part. I will come back to this part in a while. Now, coming to the SparkContext, guys, as you can see that Spark application runs a set of processes altogether which are going to run across the cluster. That's fine. Now these processes will be coordinated by the SparkContext object. And how? The SparkContext object is gonna coordinate all of these processes. When you talk about the processes, they are the individual calculations which are going to run on each and every machine altogether, right? Now, SparkContext object itself does not coordinate all of them. It needs a cluster manager. Okay, this is important. It needs a cluster manager. So by default, if you just submit your Spark application, it would be using standalone, cluster manager, or instead of standalone, you can say that Scala's own cluster manager altogether. Okay, or if you choose to use Yarn, distribution of Spark, okay, then it would choose Yarn as the cluster manager. Now again, this is again a setting which you can specify while running your program. Okay, I will show some part of that. Okay, or you can even choose mesos also for your resource allocation all through the entire cluster altogether. So the point is, you are going to have a driver program wherein your SparkContext is the most important object, apart from your, of course, your core logic, and then that SparkContext object along with the whatever you will specify in -- master. Okay, so if in -- master you say local, or if you say Yarn, or if you say mesos, depending upon whatever option you give, it will choose it will connect to a different kind of resource allocator or the cluster manager altogether, and that cluster manager would be something which will be responsible for executing your job, right? Your job across the cluster altogether, right? And the cluster manager, what exactly does it do? So I hope I don't need to tell about the cluster manager, especially to the people who are from Hadoop background, right? So think about Yarn. What does it do? So guys, typically these cluster managers are the ones who manage the entire resources. And when you talk about the resources, primarily now, to be very honest, I have never used mesos. Okay, I've never used Mesos. I've just used, this Yarn, or probably our standalone cluster manager altogether. Now, these cluster managers, as of now, Yarn focuses on two things: on the allocation of the entire memory for your JVM processes to run. That is point one. And then the second thing is it's all about so you will see that I think in the next class, in tomorrow's class, when I'm going to show how to run. So in today's class, I will show how to use Hadoop as the storage. Okay. I hope those people who were asking the question how to use it, and will you show all the possible things. So today's class, I'm going to show you how to use HDFS as the storage. But in tomorrow's class, when I will show you how to use Yarn as your cluster manager, right? At that point of time, you will see that you can provide multiple memory options and all that, right? So based on the options, whatever you will provide, these resource managers create your JVMs with those kind of settings altogether, and then they ensure that yes, your worker processes or your actual program is running on each and every of those nodes altogether, and then they monitor as well. Okay, guys, is this clear to you? The role of your resource manager, right? Balaji, Jacob, Satya, right? So in terms of Yarn, the same thing is done by the Spark, that standalone cluster manager as well. But for that, it takes the help of its own configuration files altogether. Right. So it is almost similar to Yarn resource manager, almost similar. Okay. Again, probably Vamsi, you left in somewhere in between. I'm just saying it is actually Yarn resource manager if you are using Yarn as your cluster resource manager. If you are not using Yarn, if you are using, let's say, Spark cluster manager altogether, it is also going to do the nearly the same things. Okay. Now, coming back to the point. So now these cluster managers, of course, are going to manage those resources. And when you talk about resources, this is a very abstract term. What exactly do we mean by that? It's all about your your JVM settings and all. What exactly are the JVM settings with which it has to create the entire container for you, and then monitoring of the entire process altogether, right? And the good, if you remember from, remember from your Hadoop discussions and all, this context object was something which was responsible for sending your job files and other things in the cluster, right? You remember? It actually, all of the distributed systems, they follow the concept of data locality, right? So here, basically, your SparkContext object is something which is responsible for sending your application code. When you talk about application code, so you will see in terms of SBT, right, Scala app and all, you would be creating jar files. If you are doing it in the Python, from the Python code and all, you would be creating your Python scripts and all, right? So basically, you will have to send your codes also to the executors, to the individual machines where your code is going to run. This is again done by SparkContext with the help of your entire cluster manager altogether, right? And then finally, the SparkContext executes the task and in each and every executor altogether. So now, if I come back to this slide, now I hope the slide makes much more sense, right? That you have a SparkContext object which is created in the driver program, which connects to a cluster manager, which happens to be either your standalone or Yarn or either or your Mesos thing, right? And then that cluster manager, via this cluster manager, all of your resources are sent to each and every worker node. When you talk about resources, it might be the resource as your code file, okay, which I just told you, either your jars or Python scripts, or they must be, so I am not sure how many of you are aware of something called distributed cache, right? So just like you have something called distributed cache, you can create some of the broadcast variables or some of the accumulators if you are aware of something called Hadoop counters. So when you talk about the resources and all, right, everything is okay. That's great. That's great.
Okay, so your distributed cache, your counters, and also similarly these. I mean, at the end of the day, Spark is what? Spark is also a distributed system, so it must also have nearly the same kind of things. Yeah, right, available here as well. So again, these broadcast variables and accumulators, you will see them in detail in tomorrow's session. Now, these would be the things which are like which are again some of the cluster or your entire, I would say, calculation wide resources altogether. So they are also sent along to the entire cluster, or they are coordinated in the entire cluster by the cluster manager and through your Spark context object altogether. And then whatever you are seeing on each and every worker node, they are nothing but your separate data nodes altogether, which are going to be there in our cluster. Executors. Now you talk about this executor. This is a JVM. At the end of the day, it is a JVM and nothing else. And within a JVM, you can see multiple tasks. So what exactly are these multiple tasks? What exactly are these multiple tasks, by the way, within a JVM? What do they represent? I mean, this is a very generic question, right? You must be able to guess. Right. No, Vamsi, these are not the tasks. They are the different threads altogether. Venkat Haridasu has answered it right. Okay, so you will see that, right? Codes to data. No, guys. So Harsh, they are nothing but within a JVM. Within a JVM, multiple tasks. Yes. And what exactly they are the different threads or the parallelization, whatever you would have said, and definitely some sort of cache would definitely be assigned, right? Again, that cache depends upon what exactly is the capacity. So you never say, or sometimes you can actually give some hard-coded numbers also, that I need the executor memory as so and so. I will show you. When I will show you, yarn example, at that point of time, you can actually assign the executor memories as well. Okay, but again, I don't see that as a very good practice, because if you are saying some hard-coded value, then you better need to be sure that whatever configuration you are providing, at least this much should be available on each and every worker node. Otherwise, what would happen is a specific part of your calculation would keep on failing on a specific node altogether. Although Spark has a different, so just like in Hadoop, I don't know how many of you are aware of something called speculative execution, right? So are you aware? I mean, I'm just covering some of the parts which I will anyway cover tomorrow, right? So I will not spend much time here. There are some nodes also which are coming, not a problem. Just for now, assume that there is something called speculative execution, through which it's one of the ways to improve your overall performance altogether. So through speculative execution, Spark would also be able to overcome it. Okay, but this is not really the right way. So now coming back to the point, it's all about how exactly it is coordinated, right? So SparkContext through your given cluster manager will coordinate your entire process which is happening across different nodes. Okay, and executors, they are the JVM process. Now in terms of the simple cluster manager, Spark cluster manager, they are the simple JVMs in the terms of if your cluster manager here is yarn, right? If it is yarn, it happens to be yarn, then these executor processes will be what would be the name of these executor processes? If your cluster manager is yarn, what is the name of these executors? There is a specific name. No, it is not application. It is not just container. It is not application manager. Guys, you need to refresh. You need to, exactly. So as Balaji has said, Balaji, it is only one part which you have told correctly. There is another part. Okay, so one of them would be application master, right? And after that, after creating application master, if it finds that it needs to spawn the process across multiple nodes, then the other JVMs are called yarn child. Do you guys recall? There's something called Uberization and all, right? So nearly the same thing, right? I hope others are able to recall that, right? Now, so the first JVM which will be created will always be an application master, this thing, and then there would be multiple multiple yarn children basically, which get fired based on what is the parallelization required. Right, guys? I hope it makes sense to everybody. Can we move to the next? Okay, there was a question from Vamsi. But apart from that question, I hope everybody is clear, right? So me going to the next slide and then coming back makes sense, right? What are these different tasks? So these different tasks are any instructions, whatever are running. Okay. Now these tasks can run in parallel as well. I mean, multiple threads altogether. Okay. So task essentially is your code which is running either in parallel or as a single thread. Okay, Satya? Okay. Guys, clear? Now, Vamsi, the question which you had asked about the Apache Mesos. So, again, in the Apache Mesos case also, your cluster manager is going to be Mesos, and then all of the resource management, cluster resource management would be kind of outsourced to Mesos altogether. Though, probably, I think you logged out by that time. That I told I have never worked with Mesos, or it is not even preferable, because typically it's a theory that more are the number of components in your software development, more is the chance of failure, right? So we have tested, we are good with Yarn and the standalone cluster manager altogether. So that's what I would say. But if you need some help in terms of how to integrate Mesos with Spark, if you need some of the help on that side, definitely I can provide. Okay. Balaji, clear? Vamsi, clear, right? I hope you are listening. Your connection is proper now. Just a sec. Great. Okay. I would be needing any help in this. So that's great, Vamsi. Okay, we are not planning to use Mesos. That's great. In fact, I don't know. I have also not, though I have not myself, dived deep into this, but it must be a, something popular. But I have not seen any of the implementation, even in, with my friends as well, who are working in different organizations. Now, do they run in isolation like MR jobs? Can they talk with each other? Wow, what a nice question. Satya. So Satya has asked such a nice question, and I just missed it in the, I would say, one of the brilliant questions altogether. So Satya's question is in the continuation of his previous question, wherein he has asked about what exactly these tasks are. And I just told these are nothing but, your different codes altogether. Which are running. They can be multi-threaded or some all of that I just explained. But now his next question was that do they run in isolation just like in MapReduce job, basically share nothing architecture, or can they share the states among them? Satya, am I understanding your question properly? If I try to summarize your question, it's about, do they follow the share nothing architecture, or is some sort of state sharing possible, right? Now, your question is very wide, I would say. Okay, very good and very wide. So when you talk about state sharing, but first of all, others also, I hope others are also following this question, right? Question makes sense to everybody, right? Now, coming back to the answer of it. So Satya, I will take it, I would answer it in two parts of it. Okay, if you're talking about the state sharing within the application, okay, state sharing within the application, typically, as you know, most of the distributed systems, they follow the share nothing architecture. Spark is also no different, but it allows some sort of read-only states and some sort of counters which can be shared across different, tasks, or even across different tasks which are happening across different, worker nodes altogether. Okay, so different tasks which are working within a worker node, or different tasks which are working across worker nodes, they can share the states, okay, but not always updatable. So there are something called broadcast variables. They are like read-only data, okay, they are just like your distributed cache altogether. Or you can have some sort of counters, global counter kind of a thing, right? So yes, they are possible up to a certain extent. Does that answer one part of you? I mean, if I don't tell that there is a second part of second part of the answer of your question, does this suffice? Now I'll come to the second part. Great. Now, one question or one aspect which I'm not really sure whether Satya would have thought or others would have thought is even the bigger picture. So assuming that you run your program. So let's say Satya, okay, Satya has written two programs. One, let's say simple word count, and another, let's say line count. I mean, I'm just giving very simplest. In fact, my programs are going to be that simple. Okay, the idea is to show you how to exploit it further. Now, point is, let's say you are writing a very simple program, and you are firing these two things in the cluster altogether, right? Now your one program is doing a word count, another one is doing a line count. Due to some, I don't know for what reason, okay, due to some reason you want to share the states between one application to the other. Now this is something, so it means word count is gonna run in 10 different machines altogether. You want to share the states among them, you have got the answer. Now the point is word count sharing the state with line count. Are you getting my point? Are you getting my point? That we are talking about now the state sharing across applications. If you are talking about that point, as of now, it is something which is not happening, but there is something, there is a provision for, I am not sure how many of you have heard about something called tachyon and all. They are kind of in-memory, not really databases and all, storages and other stuff, through which probably there would be an integration of Spark. I don't know when, but sometime in future, wherein the state sharing across applications would be possible. Guys, Satya, I am sure you must not have thought about the second part, or have you thought? Or others? Tachyon, I'll just T-A-C-H-Y-O-N. Got it? So there is a Jira. Should both the programs run at the same time? No, not really. They can run asynchronously. So idea is not about whether these programs are running at the same time or not. These programs can be run, I mean, I don't know. One program might be recurring, one program is very long running one.